Hello students, once again welcome to Bholanath Academy students. Now here students we are going to the relationship between mass and molar mass of gas. Gas students here we are talking about. In what are the relation moles and volume of gas? Molar volume of gas. 1 mole of any gas occupy a volume of 22.4 dm cube at a standard temperature 0 degrees Celsius and pressure 1 atmosphere pressure. This together we call as at STP, standard temperature pressure. 1 mole of any gas, whether it is hydrogen, nitrogen, whatever gas is there students, it occupy a volume of 22.4 dm3, that is 22.4 liter. 1 mole corresponds to 22.4 liter volume. It will occupy 22.4 liter. 1 mole of gas corresponds to 22.4 liter at standard temperature pressure. So standard temperature 0 degrees Celsius, pressure is 1 atmosphere. Molar volume of gas students, so here we can see molar volume of any gas equals to 22.4 dm cube. This is very important students. Now students, one example students, say for example 1 mole of oxygen gas, oxygen molecule students, that means 32 gram of oxygen gas, correct, because we are going to take the molecular mass of oxygen molecule. So molecule is 32 gram. The 32 gram word will say oxygen molecule gas equals to a molar mass of oxygen gas. This is the molar mass of oxygen molecule gas. So molar molecule of oxygen 16 plus 16, that is 32 gram of oxygen gas occupy 22.4 dm cube, that is liter of oxygen gas molecule. So that means this molar 32 gram corresponds to 22.4 liter of oxygen gas, which is equals to, in that means 22.4 liter of oxygen gas corresponds to 6.022 into 10 to 23 molecule of oxygen gas. That means in 32 gram of oxygen, this Avogadro number of oxygen molecule will be present, or you can say 22.4 liter of oxygen molecule gas. If you are taking, it occupy this much volume. In this much volume students, this much number of molecule will be there. That means 22.4 liter molecular oxygen gas equals to 6.022 into 10 to 23 molecule of oxygen. In this much volume, this much oxygen molecule, number of oxygen molecule will be present. Understanding? So 32 gram, 22.4 dm cube liter, and these all are equal. Understanding? So students, one more example. Here we have taken 1 mole of carbon dioxide gas. 1 mole of carbon dioxide gas corresponds to, that is 44 gram of carbon dioxide gas. This is the molecular mass of carbon dioxide, 44 gram of carbon dioxide gas, which is nothing but molar mass of carbon dioxide gas. Now that means this molar mass of carbon dioxide gas equals to 22.4 dm cube liter of carbon dioxide gas. So if you students, this 1 mole of carbon dioxide gas equals to 44 gram of carbon dioxide gas, which is equals to molar mass of carbon dioxide gas. This much molar, that is equal to 22.4 dm cube of carbon dioxide gas, and this in this much liter volume students, it will contain 6.022 into 10 to 23 molecule of carbon dioxide. When you see the carbon dioxide molecule students, this much number, that is Avogadro number of molecule will be present in 22.4 liter of carbon dioxide in volume, and when you weigh it students, that means corresponds to 24 gram of carbon dioxide. Understanding students? So this is the weight, this is the volume, and this is the number of molecule of carbon dioxide. So this is the relations: mole, weight, that is we can say molar mass, and this is the molar volume, and this is called as what students? This is the number of molecule of carbon dioxide. These all 4 relations students, if you know, then only you can solve the sum problem. Now students, so here students, we comes to the formula that number of molecule of gas. If you want to find out the number of molecule of gas students, gas we are talking students, so here volume word should come. Volume of gas at STP divided by molar volume of gas. If you know this, you divide it and you will get the number of molecules. The volume of gas at STP will be given to you, and this molar volume of gas, any gas, is the fixed, that is 22.4 liter dm cube per mole. In 1 mole, this much volume will occupy. Understanding? This is the formula how we are going to find the number of moles of gas. Now students, here very important examination, sometimes they are asking students questions like this problem: calculate the number of moles and molecules of urea. How much number of moles of urea present, how much molecules. So here 2 questions we are going to solve students: number of moles of urea and number of molecules of urea present in 5.6 gram of urea. That means here the mass of urea is given students. So students, how you are going to solve? So first I am writing what is given: mass of urea. Mass of urea, it is students, it is given, that is already we are getting from the questions 5.6 gram. Okay students. Now students, if you want to find the number of moles, you should know the molar mass of urea. Molar mass of urea. For that students, you should know the molecular mass of urea, which is nothing but molecular mass of urea. Urea, students, for getting the molecular mass, students, you should know the formula of urea. What is formula, students? So this is the carbonyl will be at the center and 2 ammonia will be present here. So this is the molecular formula of urea. So when you, students, see number of hydrogen, students, there is total 4 hydrogen. Plus when you see the number of hydrogen, you will find 2 nitrogens are there. Carbon is 1 oxygen is there. When you add the atomic mass, students, 4 into 1 plus 2 into nitrogen, students, what is the atomic mass of nitrogen? That is 14. 1 plus carbon, that is atomic mass is 12, and oxygen is what? 16. When you add all, students, you will get 16 unit. So this is the molar mass of urea. Once you got the molar mass, you know the mass of urea, you can find the number of moles. Students, formula is, you know, mass of urea, which is already given in gram, students, divide by molar mass of urea. Molar mass of, students, mass of urea, you got how much it is from questions? It is 5.6 gram. Divide by 60 gram per mole, in 1 mole per mole. So when you, students, divide, students, answer will come 0.0933 mole. So this is the first answer of the questions. Now, students, in second questions, you are going to find the number of molecules. Number of molecules. How much urea molecules are present in urea? Number of molecules of urea, students. For that, students, you have to multiply number of molecules, the number of moles. You have to multiply with Avogadro number. Avogadro constant, you can also say. So number of moles we got, students, 0.0933 into Avogadro number, that is corresponds 6.022 into 10⁻23. Because urea molecules, so this much number of molecules are present in Avogadro constant. So when you multiply, students, I am writing here directly answer, students. 5.618 into 10⁻23 molecules of urea will be present. This is the very important, students. This way you have to write in the examinations. This way we have calculated the number of molecules and number of moles, number of molecules of urea. Now, students, one more. This is about the when they are present in gram. Now what happens, students, if they are present, if the gases are there? For gas, students, these type of questions are coming. Calculate the number of moles and the molecules of ammonia gas. This is the gas. When the volume is given, now here volume is 67.2 dm cube, that is 16.72 liter of if ammonia is there, that means how many number of molecules will be present, how many number of moles are present, how many molecules of ammonia will be present, students. This is very important, students. Here, students, same thing, students, we are going to see. First of all, students, you should know the what is given. So first write the volume. What is given? Volume of ammonia, that is NH3, is given how much? 67.2 dm cube. Correct, students? Once you know the volume of ammonia, students, what is the molar volume? Molar volume of ammonia, that is equals to how much volume it is occupying, students? Any gas is there, that is 22.4 dm cube in per mole. Okay, students, because I have written like this, this is called a per mole. So if you, students, first question, now we are going to find the number of molecules. Therefore, number of moles. How many number of moles of ammonia will be there, students? Number of moles of ammonia is equals to volume of ammonia divided by molar volume of ammonia. Now, students, you have to divide. It is already given, that is we have to divide 67.2 dm cube with 22.4 dm cube per mole. Now, when students, here I am directly dividing. When you divide, it will come 3 when you 22.4 3 will be this. So 3.0 mole of ammonia gas will be there. Mole of ammonia gas. So this way you calculate the number of moles. of ammonia you calculated. Now students, second part is students, how many number of moles? So number of molecules of ammonia is nothing but number of moles multiplied by Avogadro's constant. Avogadro's constant students, you know this is constant for all. Number of moles you have got 3 multiplied by 6.022 into 10 to 23. So this much when you multiply students, it will comes 18.066 into 10 to 23 molecules. So this much molecules will be present in 3 moles of ammonia gas. So this way we have calculated students. These are very important for the examination. When if you like my video, please share it, subscribe it. Thank you very much.